tides in a specific location can be approximated using the periodic function shown on the graph. Okay, so the midline is somewhere in here. All right, the midline somewhere in this area. In fact, let me cheat. Why am I drawing dotted stuff? When I have a line tool, baby. Let's go. All right, so the midline is somewhere in there. So I know that there's a such thing as high tide and there's such thing as low tide. I don't know what they call it when it's right in the middle, but I know there's such thing as high tide and there's a such thing as low tide. Okay, and I'll probably get a hint when I look down at the answers, my answer choices, but I don't want to cheat just yet. So I'm just going to make up a word, and I'm going to call this mid-tide. I just made that up. Okay, so you'll get the idea. Anyway, the question is, what is the interpretation of the amplitude in this application? So hopefully you understand that the amplitude is right here. It's always the distance between the midline and like the highest value, okay, which is the same as the distance between the midline and the lowest value, but it's the distance between the midline and the highest value. So this would be the amplitude right here. Okay, so that's the difference between mid-tide and high tide. So hopefully they're going to say something like that. Or maybe they'll say it's half of the difference between high tide and low tide. I don't know. Let's look at the answer choices. Okay, is it the time between tides? No. Okay, time is like on the x-axis. This is going to be some kind of height. Okay, is it the time between high tide and low tide? No. Okay, again, every time they say time, that's the x-axis. All right, time is measured this way. Okay, we're not talking about x-axis stuff. We're talking about changes in height. So we can forget about anything that mentions time. Okay, we're looking for heights. The sum of the heights at high tide and low tide. That just doesn't even make sense. Okay, so the difference between the height at high tide and the height at low tide. That would mean you're taking the height at the highest point and then adding on a little extra, okay, for the height of the low. So it'd be this whole thing plus some extra height. So that definitely wouldn't be the amplitude. That makes no sense. Okay, now I'm a little bit at a loss because that leaves me with this last one, which I really didn't think was accurate either, but I'm going to pick it. Out of these four, I'm going to pick this last one. The difference between the height at high tide and low tide. Okay, now the way I understand it, the difference between the height would be the whole thing. Okay, my understanding would be that this would be the difference in height between high tide and low tide would be all the way. And that's not the amplitude. The amplitude is half that. So I'm going to quibble with this answer a little bit, but from the choices they provided, this is definitely the closest. So that's the best I can do. I just had one more thought before I sign off. I don't know anything about tides, so maybe my mistake was in the labeling. I know nothing about tides. What am I? Am I an oceanographer or something? Maybe high tide, you know, is this point, and maybe the midline is called low tide, and maybe this line down here is something else. I would have thought that this was the high tide and this was the low tide. But the only way this makes sense as the answer, the difference between the height at high tide and low tide, is if there is no mid tide, and really this is high tide, and in the middle that's low tide. Because then that would be the amplitude, for sure. So maybe that's what it is. You know, I don't know anything about tides. Sorry.